Linux primarily manages access to resources based on a user's ID and the groups in which they are a member. A user account in Linux is similar to user accounts in other operating systems. Before we dive into the details about users and groups, let's see who is logged onto my system. There are three commands we could use: users, who, and w. They all basically do the same thing. They just have different options and formatting of output. Let's use all three to see the differences. While w provides the most information, who is the more commonly used command. We can see that Bob is the only user currently logged into the system. On Linux servers, you could see many more users listed. Associated with the account is a username, a password, a home directory, and other information. Since Linux uses simple text files for configuration, we can see most of this in the etc password file. Let's look at the information stored in this password file. There are 7 columns separated by a colon. The first column is the username. For example, the first username listed is root. This is the superuser or administrator account on a Linux system. The second column used to be a hash of the user's password. However, people realized that this was very insecure since all users have read access to this file. As a result, the hash was moved to the shadow password file etc shadow and has restricted access. As a result, an X is placed in this column in the etc password file. Sometimes you may see an asterisk here. This is done to disable logins to the account while still preserving the account information. The third column is the user's unique identifier in the system. The root user's ID is 0. The fourth column is the unique identifier of the user's primary group. Both of these identifiers are used internally in Linux for things like file permissions and process management, both of which we will discuss in later videos. The fifth column is a text field that provides additional information about the account. For example, it can include the user's full name, their office number, or telephone number. Each piece of information is separated by a comma. We can see a few examples here for system accounts and the users Bob and Sally. The sixth column is the user's home directory, which we have already discussed in previous videos. The last column is the user's default shell. Most of the time you will see bin bash for real users of the system. Note that many of the shells listed here are user bin no login. You may also see bin false. These are used as a security measure to prevent someone from logging onto the system as this user in an interactive shell. As you can see, there are many user accounts for system processes. Linux does this to simplify managing access rights and to minimize chances of privilege escalation if someone were to compromise the accounts. If we scroll to the bottom of the file, we see that the normal user accounts start with user ID 1000. Now, let's look at the group file etc group. This file has 4 columns. The first column is the group name. We see that for most of these groups, the name is the same as the user. This is because these are the primary groups for the users. Every user has a group that is associated with just that user. It is used to simplify management of permissions. The second column is for the group password. This isn't used anymore, so an X is simply placed here. The third column is the group's unique identifier. We saw this number in etc password file when it was used to specify the user's primary group. The last column is a comma-separated list of usernames of users that are members of the group. The default groups aren't too exciting for the most part, but there are two groups that are important. The admin group indicates which users can elevate their privileges to administrator level. It is shown here as ADM, but it is also commonly referred to as the wheel group. The second group, sudo, indicates the users that are able to run commands as any user and any group. We will discuss how these are used in another video. In production systems, you will often find customized groups at the end of the file. For example, in a university, you may have a group for a particular set of students in a course. The details depend on the usage of the system. Now that you understand how all the information about users and groups is stored, let's see how they are used in the system. If we do a long listing of the directory home, we see that these directories are owned by specific users and groups. We will discuss how ownership works and its effects on permissions in a later video. There are a number of commands you can use to administer users and groups in Linux. They are beyond the scope of this course, but if you are interested in learning more about them, there are numerous resources on the internet describing their usage.